okay, to find other coterminal angles. So if you take that minus 800, I don't know if you have a calculator handy or your phone or whatever, but if you add 360 to it,
Negative 440.
okay, notice that that's not there. Do you agree with that?
Yeah, I agree.
So you add 360 again since it's negative.
Okay, so it'd be negative 440 plus 360.
But it wants two of the angles, so we're gonna have to find the other one. If you can, go to the Desmos Scientific, not the calculator. It's another. Yeah, either.
There it is.
Grab that. And if you can, I mean, it would be good to make it kind of split screen if that's at all possible.
Oh yeah.
Left and right. I would make the calculator, well, you can do either way, so that will also work. Okay, you got to drag it all the way to the right, the middle right, middle of the screen right. Oh, drag it down now.
There you go. Okay.
Okay, so like you said, you can do minus 800 plus 360 in that calculator, and then I'll show you how to do this a little bit faster. But go ahead and type in minus 800.
Negative 440 and then negative 440.
So instead of doing that, there's a slightly better way here. Well, I mean, you can keep entering it that way if you would like. Yeah, so that'll give you one, and then you got to do it again to get the next, because it wants one positive and one negative.
Right.
So you
so
have to.
Then would I just add 800?
Nope, no. So do this for me. Type in minus 800 instead of the 360 to start. Type in that number plus 360. I know you've already done this, but just okay, and then write times 1. Okay, and you see no change. Okay, now change that 1 to a 2. Okay, then change it to a 3. And this is how you do it, where you can see the numbers without having to change everything on the right there.
Okay. Cool. All right, and then pretty much like the same thing.
So let's, put the angle in instead of minus 800. You can leave that stuff there. Type in 70 and do the 360 times 1. Okay, and that's 430. Is that there?
Yeah.
Yep, so that's our positive. Now you got to subtract 360. So you could keep going, but you've already got the positive one. So you want to subtract 360 times 1. Perfect. And then minus 290, and that one's there. If it wasn't there, you do times 2 to get the next one, and so on.
Okay.
So 615 there. There it is. So you've got the positive one, so you got to go negative.
Right.
So to do that, you have to subtract 360. You can't keep adding. It's just going to get bigger each time. Does that do you follow that?
So I created 255 negative.
No, it stays positive. Yeah, the angle is always whatever the angle is that's given. You're going to keep that the same, and then you're either going to add 360 or subtract 360 multiple times depending on the problem. And then you just look for the number there, and you need one positive and one negative. Yeah. So again, enter that minus 125 as your angle. There it is. Perfect.
Okay, and then that was not that one.
So if you drag to the middle right, not the top right, drag it down, it'll auto snap to that left side, or right side, depending on what you got. Good.
Cool. I think this was, yeah, that was wrong.
Okay. Right. So I will have to snip these in to be able to best help you on this stuff.
Okay.
So let me grab my snipping tool. It's the kind of thing where it's like some of the stuff I really do enjoy just talking you through, because I think you're getting a lot of benefit from doing it, the motions of the calculations yourself. But for this one, there is no other way. So if you got your pencil and paper out, definitely would recommend taking some notes. But let me show you how to work through this problem. So every triangle that we're probably going to look at here is going to be what's called a special triangle. There's two types. There's 30, 60, 90, and then we'll talk about the other one when we see it. So there's what's called a reference triangle. And if this is 60, that means that this other one is 30. And the reference triangle says, oh, you're not seeing my screen. I'm sorry. I didn't realize you weren't seeing my screen. Now you're seeing my screen. So what I've done here is just drawn a 30, 60, 90 triangle over here, similar to yours. But what I'm going to use what's called these reference sides. So the side across from 30 is usually labeled X. The hypotenuse is 2X. And then the long leg is X root 3. Okay, now you're like thinking, well, why does that matter? Well, what you do is you set the known side, which is 9, equal to the reference side. And so what I mean by reference, I mean the one that's identical to it, it's 2X. Okay, so in this case, you solve for X by dividing by 2. So that means X is 9/2. Okay, now to be clear, X is referring to this X over here on the reference triangle, but it just happens to be the same X that you're looking for. So this is your answer. But the thing we're going to keep doing over and over again is we're going to draw this reference triangle. We're going to set the known side equal to the reference side. There's no way to do this otherwise, unfortunately.
Okay.
This is the only way to make this work. So
Okay.
whenever you're ready, you can share the next one. All right, so this one's really similar to the last. I'll grab a snip here and share my screen. All right, so let me share my screen and we'll look at the next one here. Okay, so again, it's kind of the same deal. It's a 30, 60, 90 triangle. The hypotenuse is given. This is 30 degrees. This is 60 degrees. So the short leg is across from the 30, and that's usually referred to as X. It's really the reference, though. It's not the same X as that. The hypotenuse is 2X. The long leg is X root 3. Okay, and again, you set the known side, which in your case is 6, equal to the reference side, or hypotenuse with hypotenuse, 2X. And then you solve. So in this case, you just divide by 2. So X equals 3. X refers to the short leg down here, short leg, which is the same as that short leg there, which is 3.
Okay.
So depending on the problem, you could be given the hypotenuse, the long leg, or the short leg.
This is so confusing to me. I don't know.
Whenever you're ready, you can share your screen and we'll look at the next problems.
Got it.
Unfortunately, I'm not seeing anything at the moment if you're sharing. There it is. Okay. Yeah. Okay. So do you see that in this problem, you are given the hypotenuse,
Yeah.
the hypotenuse of the triangle? All right. So I'm going to share my screen. That's important. That's first kind of understanding that needs to happen here. So when you're given the hypotenuse, okay, in a 30, 60, 90 triangle, and again, I'm just going to draw the reference triangle again. So the reference triangle is wherever the 30 degrees is across from it is always what's called x. And then the hypotenuse is 2x, and then the long leg is x root 3. And you've seen I've drawn this triangle in the previous problem. It had a different orientation, but it's the same triangle because the x is always across from the 30. Okay. Now, you set your known side equal to the reference side. And then you divide by 2. So x equals 6. Okay, but x here refers to the short leg. Okay, the short leg right here. And then you have to decide, is that what I'm actually trying to find? And in this case, it is. So far, like the way we can summarize what we're doing right now is you take the hypotenuse and you divide it by 2 to get the short leg. So let me try to write that in words. Hypotenuse divided by 2 equals the short leg. Okay.
And the hypotenuse is the
Longest side.
the longest side. Okay.
It's the longest side. It's usually across from the 90. Across from the 90. You know, that right angle there.
Mm-hmm. I'll share my screen.
Okay, so do you see how you're given the hypotenuse in this problem?
Mm-hmm.
So the short leg, which is across from the 30, is the hypotenuse divided by 2.
Mm-hmm. So, wait, so I divide 13 by 2 or 30 by 2?
The side length is 13.
13. 6.5.
Yes.
I'll take it. Would 8 be the longest side?
So this one is different. This is a different type of triangle. Could you move through the questions and see if there's any more 30, 60, 90 triangles? Nope. Nope. Okay, let's go back because this is the only kind of new one. Yeah, one more time. All right, let's go forward to this one. Yeah, so in a 45, 45, 90 triangle, which is what you have here. I'm gonna snip this in and share my screen. Looks like the next few may go a little faster. Some of them are just calculator problems. Okay, so in a 45, 45, 90 triangle, and that refers to, and I guess I didn't say this, a 45, 45, 45, 90 refers to the angles. And if this is 45 degrees and this is 90, that means this is also 45 degrees. Okay, so this is another like special triangle. It's called a reference triangle that you might need. So the way it is organized is each leg is called x because they're the same. And then the hypotenuse is x root 2. And again, you set the known side 8 equal to the reference, which is x. Okay. And that means that x is the leg of the triangle. So both of the legs are 8, which means your value of x is also 8.
Okay.
Coming outside? Come on, let's go warm up.
Mm. No. No.
Okay, so again, in a 45, 45, 90 triangle, both of the legs have the same value.
So it'd be 7.
Yes.
Okay.
I thought there was a problem that said like cosine of 14 degrees. Was I looking at something else?
Yeah. Let's see.
Okay, so go ahead and go to the, like, make this the left screen. I want you to get that Desmos calculator up, but I want you to be able to see what you're going to enter. So just click and drag and go to, yeah, right there's perfect. So go to your right there and type in cosine 14, parentheses 14. And just most importantly though, is you got to have it in the right mode, in this case, degree. So what I don't know is which one is selected.
Really, this one is degree.
I guess you could answer it and see. Let me check on my side. I don't really kind of like that layout they have. I got 0.9, yeah, 9703. That looks good.
Would it be
You have to round to 4 decimal places.
4?
Yes.
Would it be 97, like 9703?
Yes. You got a 2 there, yeah. Okay, that should work.
Cool.
Okay, so this one I will have to share my screen to be able to help you with. The angle B you can actually find right away because it is the sum of the 3 angles has to add up to 180.
Mm-hmm.
So you can see that A is 55 and C is 90. So B has to add up to 90 with the A value of A. I'm going to share my screen, but sometimes you can get some of the information pretty quickly. So I'm going to just redraw the triangle over here. And what I was trying to emphasize that this is 55, this is 90, okay? And then angle B is over here. So 55 plus 90 plus B has to equal 180. Okay, so you can solve that for B. You can figure out the missing value. Now, if you don't like that, 55 plus B has to equal 90. And why is that? Well, we already have 90 here. So if all 3 of them add up to 180, when you subtract 90 from both sides, well, you get down to 90. So what is the value of B?
45.
Try again. And you got that calculator, so it's okay to use it for all these calculations. Just
35.
35. All right. Okay, so that one's pretty straightforward. Now, to get the sides, this is where you need to have more work here to do the sides. This is 17. So relative to this angle up here, okay, we have three possibilities. We have sine, we have cosine, and we have tangent. Okay, so if we want to find, let's say we want to find B, we need the opposite and the adjacent. Do you see how tangent is opposite over adjacent?
Yeah.
That's what TOA means, or the OA means opposite over adjacent. So 17 is opposite. Tangent 55 equals 17 over B. Okay, now to solve this, you can actually just swap positions of these two. So you put that B in the top left and you put that tangent 55 in the bottom right. Your mode has to be in degrees.
Um, 11.90.
Okay, and make sure you round to the correct number of decimal places. I don't know what it says here. Okay, so we got that value. So we're going to find side C next. Let me know when you're ready for that.
Okay. All right, I'm ready.
Okay, so to relative to this angle, to find C, we can use the opposite over the hypotenuse. So opposite and hypotenuse is sine. Okay, so the sine of 55 equals the opposite 17 over C. So we have these three options, and relative to this angle, we choose the one that works best for the thing we're trying to find. So in this case, again, you can just swap positions with those. So C equals 17 divided by sine 55.
Um, 20.75.
Okay, so go ahead and enter those and see if it's what you want, if it gives you the right answer there.
Yes. Got it.
Okay, so your Desmos, I think, has a cotangent in it. So give that a try. Make sure you round to the right number of decimal places, so on.
What do I do?
So it doesn't understand cotangent. So you have to remember what cotangent is relative to something that you do know. So cotangent is the reciprocal of tangent. So if you do 1 divided by tangent, you get the same thing as cotangent. So type in 1 or type in tangent. Yeah, that would be fine. And then do a 1 divided by in front of tangent. Not there in front of. You'll want to undo that. There's a undo button there next to the degree, to the right of the degree. There's that. That means undo. Do it one more time. One more time. There you go. And then in front of tangent, to the left of tangent, type 1/. Okay, so it didn't take it. You got to put tangent 6 in the bottom.
$9.51.
Sounds reasonable. Make sure you're in degrees. I guess
Yeah,
it's
I
okay.
know.
Yeah, I mean, that's possible. It's just sometimes none of these numbers make sense because they're not meaningful for us.
3.43. Oh, 4 decimal places.
Yes.
I guess 9.5144.
Yes.
Yeah. Okay.
All right. So again, this one's kind of like that problem we just did where you should be able to find angle A really quickly. Angle A plus angle B have to add up to 90. So what is the value of angle A?
1.
Angle A plus angle B have to add up to 90. So what number plus 72 gets you to 90, or like you're doing there, you can take 18. Very good. Now I want you to be able to do that at least real quickly on an exam. I want you to be able to just write it down and get it. It's positive 18 though, because negative 18 plus 72 gets you the other direction. All right, so let me share my screen here. And you'll notice, and I hope you're taking notes. Obviously, I'll send these to you at the end, but this can only help here. So this is 18 degrees. This is 72 degrees. Okay, 90's there, and then I'm just labeling the side here 12.8. So to find, let's say we want to find A. Okay, so relative to this angle right here, A is the adjacent, and we have the hypotenuse. So katoa. Which of these three is the adjacent and the hypotenuse? And it's cosine. So we write cosine 72 equals the adjacent over 12.8. Now, in the previous problems, we just swapped positions with these. We don't want to do that here because the variable, see how the variable is in the numerator?
Mm-hmm.
So we want to get rid of the denominator. We do that by multiplying both sides by 12.8. So that clears the variable, making it by itself. So A is 12.8 cosine 72. So go ahead and calculate that and round to the right number of decimal places. I think it's 2.
Mm. Um, 3.95.
Okay. You can go with that. I'm not checking. I will if we run out, we have some issues. So to find angle B, B is opposite this 72. And then we have the hypotenuse. So I'm going to use sine because sine is opposite and hypotenuse. So like you have to use that to figure out, you know, which one to use. So sine 72 is the opposite, which is B. B is opposite 72 over 12.8. And again, you're just going to multiply both sides by 12.8. And that's on both sides. So your B is 12.8 sine 72.
$12.17.
Okay.
Or would it be 12.18 because it says to round to the nearest hundred?
Yes, rounded 2 decimal places. Hopefully it's not that sensitive. It'll give you it'll accept even that.
So it didn't accept 3.95.
Okay. So that's 12.8 cosine 72. Okay. So I I get 3.97 on that. I guess it is that sensitive.
No. It's not right either.
All right, go ahead and share your screen. I'll have to take a look here.
Okay.
So another possibility is that they are using the Pythagorean theorem to solve for the sides, which really shouldn't impact what we're doing, but for some reason it is. Yeah, I mean, I'm looking right here at the numbers. It's 3.9. Oh, no, I'm sorry, 3.96. Not 97. That's all it is.
Okay. I'm thinking that's right.
All right, so secant is not given in your Desmos. Secant is the reciprocal of cosine. So you remember how we did it for tangent? We did 1 over tangent. So here you have to do 1 over cosine because the reciprocal of secant is 1 over cosine.
Okay. Times 11.
Cosine requires you to put something in parentheses next to it.
Oh, okay.
Not there though. That is times 11. So you have to go back to the denominator and put cosine parentheses. Like that, yes. Okay, and then 4 decimal places this time.
1.29.
What are you looking at there? I mean, I see 1.0187.
Yeah, that's what, but it says to round it to 4 decimal places.
Right. So you record the first 3, 1.0187. I'm sorry, 1.018.
Yeah.
So go ahead and write that 1.018. And then you decide, you look at the 7 and you say, well, the number next to it is a 1. So that rounds it down to 7.
Right.
But you always write the first 3.
Got it.
And well, most of the time. I mean, there's probably 1 or 2 exceptions. Okay. So this one is similar to ones we've been doing. What is the value of angle B? What do the 2 angles A and B have to add up to?
26.
26, yes. All right, so I'll share my screen and we'll work through the rest of this together. So if you've noticed, I've been drawing the triangle every time we've been working through problems. 64 degrees, I'll just leave that one. I won't make the other one here. And then angle A is 7.4. And we want B and C. And these are our 3 options. So Katoa. So relative to 64, what is the 7.4? Is it opposite, adjacent, or is it a hypotenuse?
Opposite.
It's the opposite. And let's say we want to find B, that's an adjacent. So we'll say tangent 64 equals 7.4 over B, opposite over adjacent. We can switch positions. So B equals 7.4 divided by tangent of 64.
Uh, 3.609 or 3.60.
So here's what I heard, 3.609. Okay.
Yeah, 3.60.
Well, the 0 is the one we're looking at, but this 9 causes it to go up.
Right, so 3.61.
Yes.
Right.
Okay, now to find C, again, we're given the opposite and we want the hypotenuse. So sine is opposite on hypotenuse. So we're gonna write sine 64 equals opposite divided by the hypotenuse. Again, you just switch positions on those. So C equals 7.4 over sine of 64.
Um, 8.23.
Okay.
Okay.
All right, so can we just kind of move forward just to see how many other types of problems are left? Just to give me a, so that one's a calculator, but how many more problems do you have after this? 18. Okay, so let's do the two triangle problems. If you want to go back to either this one or the one before it, it doesn't matter to me, but some of those you'll be able to do pretty quickly. Is this where we're at, 14? Okay. We just did, didn't we just do this one?
No.
No.
We did
Oh,
13.
okay, there it is. Yep. The numbers look really similar. So
Yeah.
can you figure out the measure of angle A for me?
Yeah. 54.
54. Yep. All right, so I'm gonna share my screen and we'll look at the rest of this problem together.
Okay.
So I'm gonna draw the triangle. The side that they give us B is 36, and then they tell you that A is 23, and we want B and C. So again, your options are so, Katoa. It's good to write these each time to remember them. So from this angle right here, what is 23? Is it an opposite, adjacent, or is it a hypotenuse?
It's an adjacent.
It's adjacent, and B is an opposite.
Right.
So that means we're going to use tangent. And we write tangent 36 equals opposite B over adjacent 23. And this time the variable's in the numerator. So we don't have to swap positions. We have to just clear that 23 by multiplying both sides by 23. So B equals 23 tangent 36.
$16.71.
Okay.
Okay.
So again, we have the adjacent, and now we want the hypotenuse. So that's cosine. Cosine of 36 is adjacent 23 over hypotenuse C. Now this time we have to switch positions because the variable's in the bottom. So C equals 23 divided by cosine of 36.
Uh, 28.43.
Okay, go ahead and enter those.
Cool.
So we should do the next triangle problem that's given. That way we get this done. So measure of angle A, what do you say?
74.
74. So B is 16. All right, and then little b is 14. A and C. So again, like, what do we have? What do we want? So we've got so Katoa. And again, relative to this angle right here, A is adjacent and 14 is opposite. So that means it's cosine. So cosine of 16 equals A over 14. How do you solve for A? Well, you gotta clear the fraction here.
I can't see your screen.
So you multiply by 14 on both sides. Are you still sharing your screen?
Yeah.
Okay, well, you gotta let me know if I'm not sharing, because so. All right, so if you're seeing my screen here now, you'll see that I made the triangle, labeled the side 16, and 14 is across from it, A is adjacent, and that's why we use cosine. So the net result here is 14 cosine 16.
All right, 13.45.
And then similarly, to find C, I'm sorry, this is not correct. This is not correct. So the tangent of 16 is opposite over adjacent. It's 14 over A, opposite over adjacent. And so we can swap positions here. So A equals 14 divided by tangent of 16.
Mm. 48.82.
Okay. And then C is actually the one that you would use cosine for. The cosine of 16, I'm sorry, the sine of 16, boy, really messing up here. The sine of 16 is the opposite, 14 over C. Switch positions, so C equals 14 divided by sine 16.
Wait, so then would it be 50.80?
Possibly, yeah.
Okay.
So whenever you're ready, go ahead and share your screen again. I'll have you do the last 2 or 3 calculator problems.
Okay.
So cosecant is reciprocal of sine, so that you want to write 1 over sine for instead of cosecant. And then it's sine parentheses of the angle 59. So 1.166, and then you look at that third 6, and then the number next to it is a 3, so it stays like that.
Whoa. Oh, I didn't put the 1 in.
You still need you still need that third 6. There you go.
Cool.
Okay, sine you just enter as is. You want to clear all that out. We got 0.390.
It would be 0.4007.
390. You type in the first 3 digits if you're rounding to 4 decimal places. Then you look at the 7, the next digit, and you look at the number to the right of it. Is the number to the right of 7 going to cause it to round up or round down? It stays down. All right, I'll see you in about 10 minutes, and we'll keep going.
Awesome. Sounds good.
Please use the other booking, and I'll see you shortly.